So this one is January 2022 paper. We'll do the MCQs first. Element X is in a group 2 of the periodic table and element Y is in a group 7. X and Y not the symbol. What is the formula? So X is in group 2. Group 2, the valency should be +2. And group 7, the valency should be -1. So what will be the formula for compound form when X combined with Y? Because when we write the formula, we just simply cross multiply. So this 2 is with X and one with, sorry, this 2 is with Y and 1 with X. So it will be B. Under what conditions does the compound X and Y conduct electricity? Because X is a metal, Y is a non-metal. So means it will be an ionic compound. And under what condition the ionic compound can conduct electricity? So ionic compound conduct electricity when they are molten or they are dissolved. So either in a liquid or in aqueous solution. Which of these compounds was highest melting point? Highest melting point means we want the maximum attraction between the ions, and the maximum attraction between the ions. The size of the ions should be small for a maximum attraction, and the charge should be a large charge. They all have the same charge like +1, -1, +1, -1, +1, -1, +1, -1. But for potassium, how many potassium ion, how many electron shell will be there? It will have 3 electron shells. Fluorine, the chlorine configuration. So size, which one will have the smallest size? Which two ions? That will be sodium and fluoride. Because sodium, first shell, it will have 2 electrons, second shell, 8 electron. And fluoride, the first shell 2 and the second shell 8 after the transfer of electron. So as a result, they have only 2 shells and the charge on each of them is +1. So then we check the size. The smallest size is sodium fluoride. Because the chlorine will have 3 shells, potassium will also have 3 shells. So that's why B should be the right answer. So melting points of ionic compound depends on the size of the ion, should be small, because melting point depends on the attraction and attraction depends on the size and the charge. Drop of aqueous solution of a green copper to chromate. So we have copper ion and we have chromate ion CrO4 with a charge -2. Is placed in a dam filter. What is observed when we pass? So what is the appearance or what is the color of the copper? Copper ions are blue in color. And what is the color of the chromate ion? Chromate, dichromate is orange, chromate ion is yellow. And copper is blue. So because this is a positive, copper is positive. So where it will move towards cathode. And chromate is negative, so where it will move towards anode. So where we'll observe a yellow color will move towards anode, which is the positive terminal, and the blue color will move towards the negative terminal. So that's why C will be the right answer. With of these ions, isoelectronic has a smallest radii. To have the small, they all have the same number of electrons. They all have 10 electrons in their outermost shell. But here 7 protons are attracting, here 9 protons are attracting, here 11 protons are attracting and 13 protons. So 13 protons are attracting. So each electron will experience a stronger attraction. So as a result, what will happen? The size of the ion will be small. So the smallest is aluminum. And if the question was the largest ionic radii, the one which is having more electron and less proton, in that case, it will be nitrogen. Which properties of a cation result in a greater polarization? For a greater polarization, charge of the cation means a positive ion. The charge on the cation should be large and the size of a cation should be small. So small size and large charge will cause a maximum polarization. Like example, if we talk about, say, sodium is there and we have magnesium. So magnesium will cause a greater polarization as compared to that of chlorine because it has a greater charge and it has a smaller size. Which properties of anions means the negative ion result easily polarized. So this time the size of the anion, when we talk about the cation, the positive ion, for a maximum polarization, the charge on the cation should be large and the size of the cation should be small, the positive ion. But what about the negative ion? The negative ion for a maximum polarization, it should have a larger radius, like, and it should also have a large charge for a because large charge means like likely to have more electrons. So easily polarized should have a large radius and large charge as well. Because if a large charge is there, attraction will be stronger. As a result, it will be more greater polarized. And if the size is larger, as a result, the electrons are far from the nucleus, so it will also cause maximum polarization. What is ionic equation for a reaction between aqueous barium nitrate and sodium sulfate? So barium nitrate and sodium sulfate gives barium sulfate, which is a solid precipitate, and sodium nitrate. So we cancel out the common, so state symbol, this will be aqueous. All nitrates are aqueous. Group 1 salts are soluble, solid and aqueous. So we cancel out the common ion in aqueous solution. So this will cancel and sodium cancel with sodium. So we are left with barium ion and sulfate ion give barium sulfate. So one barium ion and one sulfate ion give barium sulfate. So that's why D should be the right answer. Which of these molecules, when we write, if we want to write an ionic equation, first we write the equation. We have barium nitrate is reacting with sodium sulfate. As a result, it will form barium sulfate plus sodium nitrate. This is a balance equation. If we write the state symbols, all nitrates are aqueous, aqueous, solid, aqueous. So we cancel out the common ion in aqueous. Sodium ion here, sodium, so they cancel out. Sulfate is here aqueous, but here solid, so we cannot cancel out. Nitrate is in aqueous and nitrate also in aqueous, so we cancel out. So we are left with barium ion and sodium is already cancelled, so we are left with sulfate ion and it will give barium sulfate. So this will be the ionic equation. Ions are always aqueous and then the precipitates, the substance which is insoluble should be solid. Which of the molecule is a non-polar? So when we talk about carbon dioxide, there's a double bond. Oxygen is partial negative and carbon is partial positive. So both oxygen will attract the electron with the same force. As a result, they cancel out the effect of each other. Like example, if this is applying a 10 Newton force, this will also be a 10 Newton, but in opposite direction. And because the molecule is linear, so they cancel out the effect of each other. So as a result, even though the bonds are polar, but the molecule will be a non-polar. So A will be the right answer. About HCl, because H and Cl, so this will be partial negative and positive. Bonds are polar, molecules are also polar. In case of a water molecule, because it has a bent or a V-shaped structure, so as a result, partial negative and positive, so they don't cancel out each other. The two, if it was a linear, it was like carbon dioxide, then they can cancel out. But it is a bend, so the two hydrogens are not able to cancel out the effect of each other. And same thing for ammonia. One of them is into the plane, one is out of the plane. So they are not able to cancel out the effect of each other. So that's why A is the right answer. The concentration of a nitrogen dioxide in a sample of a air is 0.5 parts per million. What is the percentage of a nitrogen molecule in this sample of air? So the formula, concentration in ppm is equals to mass of solute divided by the mass of solvent or amount of solute into 1 million. This is a formula to for a concentration in ppm. So this is given 0.5 according to a question. This mass of solute over mass of solvent into 1 million. This 1 million is divided, other multiplied, other side will be divided. So this will give us 0.5 divided by 10 raised to power 6. This is the ratio of mass of solute over mass of solvent. Now we want the percentage. What is the percentage? So the percentage of nitrogen dioxide is equals to mass of solute divided by the mass of solvent or volume of solute over volume of solvent into 100. That's how we work out the percentage. Mass of solute over mass of solvent is 0.5 divided by 10 power 6. Means this whole factor, when we worked out, it is 0.5 divided by 10 is power 6 and then multiply by 100. So 0.5 multiplied by 100 divided by 10 is power 6. That will give us the percentage, that will give us the concentration in percentage. So when we solve, this will match with option C. Is it clear how we converted? Is it clear this one? How we converted the concentration in ppm to the percentage? So first we work out the ratio and then ratio we substitute in the formula of percentage. We get the concentration in percentage. Ethane react with bromine in the presence of the ultraviolet radiation. What is the equation for this reaction? Equation they are asking because alkanes undergo a substitution reaction. Substitution reaction, like we have C2H6 plus Br2. One bromine will take position of hydrogen and hydrogen take position of bromine. So it will be C2H5Br plus HBr will be there. So B will be the right answer. Then ultraviolet radiation. Why we need ultraviolet radiation? The main purpose is to break the bond of the halogen. So homolytic bond breaking so that it produces a free radical and these free radical can attack on the alkane. So homolytic bond breaking. That's why A should be the right answer for this. All alkanes have same, what is same for them? Because alkane is a homologous series and what is the characteristic of the homologous series? They all have the general formula. Because all alkane, we can find them by CnH2n plus 2. In question 12, a single molecule of a decane is cracked. Which of these mixture could not be formed? Decane means C10 and H. So the total sum should be C10 and H22. So if it is pentene, it will be 5 and 10, and pentane, it will be 5 and 12. So this sum will be equals to 22. When we check this, C2H4, C4H8, and C4H10. So this sum 12, 22, the sum of hydrogen and 2, 4 and 4. So again, it will be 10. Propene C3H6, propane C3H8, and butene C4H8. So when you check, because propene is there, so 6 hydrogen, propane is there, 8 hydrogen, makes 14, and 14 plus 8 makes 22, and 3 plus 3, 6 plus 4 makes 10. But in hexene, C6H6 and propane C3H8. So this will make 9 carbon, not the 10 carbon. So that's why D is the right answer. Because the total sum of carbon and hydrogen before and after should be same. How many structural isomers have the formula? So how many structures of dichloropropane we can, 1,2-dichloropropane we can make? So if we have 3 carbon atoms, first, both chlorine will be the first. The second structure, one chlorine with the first, one with the second. The third structure, one chlorine with the first and one chlorine with the last. The fourth structure, the 2 chlorine are there at the center. So, and there is no other, like if I draw the next one, it won't, it will be similar to that of this one. So 4 possible structures. Hydrogen I did not draw, I just changed the position of a chlorine according to, and we cannot make a branch because 3 carbon branches start with the 4 carbon, not with 3. So we cannot make a branch here. In question 4, the equation for a complete combustion of a hexane is C6H14 plus 9 by means 9.5 oxygen gives 6 carbon dioxide and 7 water. How many molecules of a carbon dioxide are formed when 2 exponent minus 3 moles of hexane? So hexane is C6H12 and we need carbon dioxide. So the ratio between them according to is 1:6. So if we have 2 into 10 power minus 6 minus 3, so this will be X. We cross multiply. So how many moles of carbon dioxide to multiply by 612 into 10 power minus 3 moles will be there. After getting these moles, we need the number of the molecules. So we multiply by Avogadro. 1 mole contains 6.02 exponent 23. So we multiply by 6.02 exponent 23, not minus, plus 6.02 into 10 power 23 we multiplied with the number of the moles. So this will give us a total number of the molecules of carbon dioxide. That is 7.22 exponent 21 will be there. So moles multiplied by Avogadro's constant will give us the total number of molecules. Which pollutant cannot form when alkane fuels are burned in the car engine? So when we have alkane, hydrogen chloride is not, because alkane, like example, octane is there. So when we burn octane, because these fossil fuel contain trace of sulfur, so sulfur dioxide can form. Carbon particulates can form due to incomplete combustion. Carbon monoxide also incomplete combustion. But there is no chance of hydrogen chloride form by a burning of hydrocarbon because chlorine is not there. The trace of a chlorine is not there, so there is not a single possibility of hydrogen chloride formation. Iron 3 oxide is reduced by hydrogen in two-step process. What is the maximum mass of iron that could be produced from 3.99 tons of iron oxide? So we'll use a ratio. We can take the ratio of the mass. First, we'll take a ratio of mass of these two, and then we'll take a ratio of mass of this one. So if we take the ratio of the mass, 2 Fe2O3 and 2 Fe3O4. When we are taking the ratio of the mass, remember you take the total. including the coefficient of the molecule. So mass of iron is 55.8, because first mass of this iron 2 oxide, iron 3 oxide, 55.8 multiplied by 2 plus oxygen is 16 multiplied by 3. And this whole is multiplied by 3. What is the total mass? This will be 48 plus 55.8 multiplied by 2. And then the whole answer is multiplied by 3. What's the total mass here? Use the calculator, find the total mass. 55.8 multiplied by 2 plus 16 into 3. This will be 48. 447. Okay. So this mass is 447. What about the mass of iron, the second compound of iron? So it will be 55.8 multiplied by 3 plus oxygen is 16 multiplied by 4, and the total is multiplied by 2. What is this total mass? Okay, this was 477. What about the this mass of this compound? 461. So the ratio is 477 is to 461. So if we have 39.9, so this will be x. We cross multiply. So what is the answer? It will be 39.9 multiplied by 461 divided by 477. When we take a ratio of the mass, we are taking the whole mass of the compound given in the equation. What's the answer for x? 39.9 multiplied by 461. The mass of an iron that could be produced from 39. We want to find what is the mass of iron which is produced by 39.9 tons of iron oxide, this compound. So if we have 39.9 of iron oxide, how much? First, we are finding how much this compound is produced, and from this one, we'll find iron. No problem. The unit conversion is not important. When you're taking a ratio, the unit conversion is not important. Like these two are in grams, and if you take a ratio in the gram and the ratio in the tons, you'll get the same answer. So it does not make difference. What's the answer? 39.9 multiplied by 461 divided by 477. 38.561. So this one we are getting 38.561 gram. Sorry, tons. Now we'll take a ratio of the mass of these two. So it is Fe2O3 and 3Fe. So what is the mass of Fe3O4? This is Fe3O4 and 3Fe. What is the ratio of their mass? So this total mass will be 55.8 multiplied by 3 plus oxygen is 16 multiplied by 4. What is the total mass of Fe3O4? 16 times 4 and 55.8, 231.4. So 231.4. And what is the mass of iron? Iron is 5.8, then multiply by 3. So 55.8 multiplied by 3. What is the total mass of iron? 694.2. 694.2. In the question now, when we calculate it, if we were having 38.561, then this should be x. Cross multiply. So 38.561 multiplied by 694.2 and divided by 231.4. What's the final answer? But how 55.8 multiplied by 3694? There's a mistake, Abdullah. You did a mistake because it is 55.8 multiplied by 3. It cannot be 694.2. The mass of iron is 55.8. You are just multiplying by 3. This value you did not calculate correctly. Yes, 167.4. So if this was 38.561, so this will be x. Cross multiply. You get the answer. So 38.561 multiplied by 167.4 and divided by 231.4. What's the answer? 27.89. So it matches with 27.9. So C should be the right answer. Is it clear? So what we did, first we were having a mass of iron oxide. From mass of iron oxide, we got the mass of Fe3O4. And then from mass of Fe3O4, we get the mass of iron as the two equations. So from this mass, we work out Fe3O4. And from Fe3O4, we work out how much Fe is there. And no need to convert the unit because when you're taking a ratio, even if it was kilogram, gram does not make difference. If you substituting in gram, final answer will be in gram. Substituting in kilogram, final answer will be kilogram. Which solution contain the greatest number of ions? So first we find the moles. How to work out the moles? Concentration into volume. So means 0.5 multiplied by 0.02 because 20. And how many ions are there? One potassium and one chlorine. So this final answer multiplied by 2. Same way, the concentration is 0.03 multiplied by volume is 0.4 already in dm cube, so no need to convert. And then the final answer, because one potassium and one chlorine, so final answer multiplied by 2. Here we have a concentration 0.6 and the volume is 10, which is 0.1. Because like it will be 10 divided by 1000, so 0.01 multiplied by total number of ions. It contains one calcium and two chloride, so it contains three ions. And here 0.04 multiplied by 0.15 and multiplied by one calcium and two chloride, so total three ions are there. This will give the one which will have the highest number of moles of ion, that will have the highest number of the ions. So B will be the answer. You will get the highest value for B. Potassium chlorate 5 decompose on heating to form oxygen. What is the atom economy by mass of formation of oxygen? So percentage atom economy is the mass of a desired product. Our desired product is oxygen, so it will be oxygen is 16 multiplied by how many? 3 multiplied by 2, 6. Total mass of oxygen divided by total mass of a compound. So total mass of a reactant or a product. So the total mass of a reactant product, it will be 2 multiplied by potassium 39.9 plus chlorine is 35.5 plus oxygen is 16 multiplied by 3. And then whole is multiplied by 2. And this answer multiplied by 100, that will give us a percentage atom economy. So it will be 39.2 or C will be the right answer. So percentage atom economy is the mass of a desired product divided by total mass of a reactant into 100. Is it clear, this one?